113 base flow, right? So we subtract 113 from the entire data, okay, minus equal, and then we get these values, and then we add all of these together to get this, okay? And each of these block is called ordinate. Okay. So so R sub d, so this is the depth of unihydrograph. So we're using the this equation right here to get depth of direct runoff. That's what we're trying to do right now. So we know delta T and we know Q sub I. So we know delta T is 6, right? The time interval of direct runoff hydrograph is delta T equals 6 hours. So there you go. And then 0.36 is fixed. And then we know Q, sum of direct runoff hydrograph ordinates is this, 20060. And then the area is 5,870. So it's given in the example. Okay, 5,870. So that's what we got. And then after having all those numbers, we get 7.38 centimeters for the depth. Okay. And then the flow analysis for deriving the unihydrograph is shown in table 10.2. Column 1 is time, column 2 is discharge, column 3 is base flow, column 4 is direct runoff, calculate from 2 minus 3, and column 5 is computed by dividing direct runoff by the depth of the direct runoff, which gives the unit hydrograph. So, we have the entire direct runoff, and then we divide that by depth of direct runoff, and that's how we get the unit hydrograph. Okay. So the derived unit hydrograph is shown in figure 10.5. So yes, so we had the time, we had the original discharge, subtract by base flow, and then we got direct runoff, right? This is direct runoff, base flow, discharge, and time. And then by dividing this by, dividing this, the direct runoff, by 7.38. Okay, so dividing every number by the depth, this. Okay, so 0 divided by 7.38 divided by 7.38, 111 divided by 7.38. Okay, that's how we got these numbers. And this entire value or values are unihydrograph. Okay, so after we derive the unihydrograph from direct runoff hydrograph, next we find the duration of the unihydrograph. So I know this already says 12 hours, but we first have to calculate the loss using the phi index method and determine the effective rainfall. So the duration of the effective rainfall becomes the duration of the unihydrograph. So it's not the duration of the normal regular rainfall, which was 12 hours. Okay. So we don't know this yet. So the figure, it's from the textbook. It already has the 12 hour inside the figure. But in reality, we actually have to calculate the duration of the effective rainfall first. And then whatever the duration of the effective rainfall is, becomes the duration of the unihydrograph. Okay, so computed in column 5 of table 10.2. So yeah, so we have the unihydrograph. In column 5. So we have the unihydrograph in column 5. But to find the duration of the value in column 5, we have to calculate the duration of the effective rainfall first. So the calculations are shown in table 10.3. So table 10.3, effective rainfall and unihydrograph duration. So we have the times. We know the time intervals are 3 hours. So 3 to 6, 6 to 9, 9 to 12, 12 to 15. We have the rainfall values. And the rainfall intensity I is, amount of rainfall divided by time. So it's, millimeters divided by time. So 29.36 divided by 3, 13.42 divided by 3, divided by 3, divided by 3. Okay. And then as for the phi index value, we have to go all the way back. So this was the equation for the phi index method, right? Q equals summation of I equals 1 to n, the number of time intervals that contributes to direct runoff. I sub I, rainfall intensity, which we have, minus phi times delta t, we know delta t, right? So yeah, so we have to calculate phi index using phi index method. The calculation part is not shown here, but if you remember how to do it and get the phi index value, you get 3.34. And then lastly, to get the effective rainfall duration, we do so rainfall intensity. So rainfall intensity, these values are basically this, the rainfall hyetograph. And the phi index 3.34 will divide this hyetograph like this. And then, everything that's below is loss to infiltration. Everything that's above this is effective. Rainfall. Okay. So using the phi index, we remove the loss part, so anything that's below this index line, right? So 3 minus 4, and then we multiply it by 3 hours because that's the delta t, because right now it's in millimeters per hour, but we're looking for millimeters, which is effective rainfall, right? So we multiply we subtract 3 and 4 and multiply by 3 hours delta t to get the millimeters. Okay, so millimeters per hour that we get from this subtraction. So like 6.45 for the first one, for example. Right, so this minus 3.4 equals 6.45. And it's still in millimeters per hour. So you multiply by 3 hours to get 19.35 millimeters, and then if we add all these together, we get 7.38 centimeters. Okay, and then from table 10.3, the duration of the effective rainfall is 12 hours. Okay, so we know this is 12 hours because when we even after we subtracted all of these, we still had these numbers, right? So if some of these numbers after subtracting, like, if some of these numbers became 0 and then there's no more effective rainfall, then instead of having 12 hours, it could have been, 9 hours if it stopped here. Okay, but it's 12 hours because we still have some numbers left even after subtracting by phi index. So yeah, so the duration is 12 hours. Also, it should be verified whether the depth of runoff of the unit hydrograph equals 1 centimeters as follows. So the depth of runoff of the unit hydrograph, R sub d, is equal, this equation. And we know the delta t is 6. And then we know that the Q is 2717.4 because that's the summation of this right here. Okay, summation of the unit hydrograph. And then that divided by the area of the drainage area, 5,870, which was given. And it turns out it's actually equal to 1. So, it's verified that the depth of runoff of the unit hydrograph is equal to 1. So, so this is a unit hydrograph and it makes sense. Okay. Alright, that's the end of the slides. Thank you for watching, and I'll see you in the next one.